The Haripriya, could you solve this question? हरिप्रिया, कनिष्का, राधिका, किसी ने भी सॉल्व किया? एनीवन? You guys are not solving questions. What about this? Hmm. Do you want me to solve it?
Yes, sir.
So one more information. From now on, we'll be keeping the class instead of 9 at 10 p.m. because see the 9 p.m. class timing, it is interfering with the class timing of this one. The Kanishka, she is not able to do it. I think you won't be having any problem, na? So,
but it will be too late. He'll be tired.
and the problem is, see, the problem, you shift your different things according to that. Only 1 hour, na? Because she is not able to do it. Otherwise, it, she won't be able to attend the classes. Make adjustment 9 to 10 only, because I tried. Because earlier than that, it's not possible. Earlier we used to have it 7 to 8, na? And the other classes are there for Diva and this. So instead of 9, make it 10. Only on Tuesday and Thursday. Only on these 2 days. Rest all days is okay. Same time, 7 to 8. Okay, Haripriya?
Right.
It's just a matter of habit. You will become habitual. Means after that I won't change, because only one time I'm changing. The time won't be changing. Only on these 2 days. See what the question. What is the question? The moment of inertia of a disk. What is this dice? No, its disk of mass m and radius r about any of its diameter. See, they have already given the moment of inertia. Let me draw a disk. Don't know what happened to Shama. This is didn't say anything. The moment of inertia of disk of mass and radius are about its one of its diameter. This is its diameter. The moment of inertia is mr square by 4. The moment of inertia of this disk about an axis normal to the disk and passing to a point on its edge. See what they have asked, na? This demands perpendicular axis theorem. Actually, this was not the question. I remember. This was not the question that I have given for you to solve, right? Yes, na, Haripriya? I kept this question for perpendicular.
Yes.
I kept this question for perpendicular axis theorem. I said after perpendicular axis theorem, this you will be able to solve, because now I realized when I am drawing this question, the diagram, na, only by using perpendicular axis theorem you can solve it. See now what? This was the question that I have given. Two identical spheres, each of mass 2 kg and radius 50 centimeter. These are two spheres, each of mass 2 kg and 50 centimeters, are fixed at the end of the light rod. This is the end of a light rod. The separation between center is 150 centimeter, 1.5 meter. Moment of inertia of the system about an axis perpendicular to the rod and passing through its middle point, they are asking. This through this pink one, it's perpendicular to the rod. Now see, how do we solve it? I have given you a hint that the moment of inertia about an axis passing to the center of a sphere is 2 by 5 mr square. Now we already know the moment of inertia of this each sphere about an axis passing through its center is 2 by 5 mr square. Okay, now we have to find out the moment of inertia of this sphere about an axis, means the center, which is at a distance of 1.5 by 2, correct? 1.5 by 2, right? This you can write as 3 by 4. This is your hint. This is this axis that I'm talking about. This axis is actually passing to the center of mass. It's passing to the center of gravity. It's already IG. Similar is the case for this second body. IG is 2 by 5 mr squares because both the spheres are exactly identical. So this will be same. Now the distance is 1.5 by 4, sorry, 3 by 4 for this also. Now we'll apply parallel axis theorem for this, for each. I about D is equal to Ig plus its mass into 3 by 4 whole square. Now since for the left sphere also similar thing is there, we'll do it twice. ID net is 2 of Ig plus m into 3 by 4 whole square. Ig is 2 by 5 mr square. We'll just put the value 2 into 2 by 5 mr square plus m into 3 by 4 whole square. Now we'll just put the values and try to find the answer. 2 into 2 by 5, what is m? 2 kg. R is 1. R is 1 by 2, so it will be 1 by 4 plus 2 into 9 by 16. Two by 5 plus 9 by 4. 53 by 20. See, the value of x is 53. Now just look carefully and then see if you have any doubt. See, I have shown total solution of this, but the idea is what the important idea is that you should understand. Idea is we need to know for each mass, each sphere, the moment of inertia about the center of gravity, this axis, which I have already given as a hint in the last class. It is 2 by 5 mr square, this one. Now after knowing this, we have to find the moment of inertia of this whole body about this axis. So what I am doing, and because this axis about which I have to find moment of inertia, this is exactly parallel to the axis passing to the center of gravity, I can easily apply the parallel axis theorem for each sphere. I have applied it. Ig plus m into this 3 by 4 whole square. For the left sphere also exactly the same thing you will be doing. So the net moment of inertia about the center, this axis, is twice of this. Rest is the calculation. Is it okay?
Yes, sir.
Deva is okay. What about Haripriya, Kanishka, Radhika?
Yes, sir.
Radhika okay?
Yes, sir.
Kanishka? चलो सभी को समझ में आ गया ना? Now I'll tell you about the perpendicular axis theorem. What a perpendicular axis theorem is. The perpendicular axis theorem says if there is a body like this, I have drawn three axes. One is this, other is this, just see this one as these axes are passing through its plane. Now the third axis I'll draw. Third axis, which the white one is, it is actually perpendicular to it. Or you can say this is x, this is y, okay, this is z. We'll take it like that one. How you have to see this one? This is your body, my hand. Okay, one axis is along the plane, other axis is perpendicular to the plane, to this pen, perpendicular to it 90 degrees. The third axis is perpendicular to my hand, like this, z axis. Okay, x comma y are in the plane and z is perpendicular. Is it okay now? I'm drawing is perpendicular to the plane. In that case, according to perpendicular axis theorem, what they say, Ix plus Iy is equal to Iz. One more thing is this x, y and z axis should be perpendicular to each other. This is very important. This is a note. The concept is this. Okay, got it? Tell me what happened. Everyone got it now?
Yes, sir.
Let me give you an example. Bolo Radhika, tell me.
Yes, sir, I got it.
Got it now? Okay. Now see, I'll give you an example. This is a disk whose moment of inertia is given to me. I'll tell you just now how to find out the moment of inertia of a disk or anything about an axis. The rest of the axis you will be using parallel axis theorem and perpendicular axis theorem like this. Now perpendicular, this is a disk. Moment of inertia is given to us. It is mr square by 2. Now what they want? They want to find out, they want you to find out the moment of inertia about an axis passing through its diameter. Okay. Now you know, if I draw one more axis which is perpendicular to the x, it is in the plane. This is y, suppose. This x and y are in the plane. But remember, can I write moment of inertia of the body about x-axis is same as moment of inertia of the y-axis? So because this is a symmetrical body. Why I am saying this? Because see, if I draw this, let me draw these two axes that I'm showing. This and the another one is this. This is x and this is y. Now, if I ask you about the x-axis and about the y-axis, the body is symmetrical, no? Same, exactly same. Then
Yes, sir.
I can write Ix is equal to Iy. Because for every symmetrical body, you can do this. Now, because x and y axis lie in the plane of the body, Ix plus Iy should be equal to Iz because they both all are perpendicular to each other. This is 90 degree. This is 90 degree like that. But Ix is equal to Iz, you know, it is mr square by 2. Ix is equal to Iy. So 2Ix is equal to this. So Ix is equal to what? Mr square by 4. Similarly, Ix is equal to Iy is equal to mr square by 4. This is how you do calculation for a symmetrical body. It's not applicable for the non-symmetric body. You cannot write for a non-symmetrical body Ix is equal to Iy. Okay. Is it clear? This one, perpendicular axis theorem, how to apply? See, I'll tell you the common mistake that students do. The common mistake that students do is they don't bother about, and many of the teachers in classes, they don't tell you this also. They just say Ix plus Iy is equal to Iz, Iy plus Iz is equal to Ix, or Iz plus Ix is equal to Iy. But the important part is the two perpendicular axes Ix plus Iy you can do equal to Iz only when x and y they lie in the plane of the body. It's very important. The sum of the moment of inertia about the axis which are lying in the body, in the plane of the body, sum of those two, and they are perpendicular. The sum of those two is equal to the moment of inertia about the perpendicular one which of to the body. That's one. Now, if you have understood this, this for a disk, I have told you how to find out Ix and Iy. Use the perpendicular axis theorem. Now you try to solve this question that I have given. You may have to use perpendicular axis theorem or also the parallel axis theorem. See, let me explain you the question. I was explaining it now. Moment of inertia of a disk of mass m and radius are about any of its diameter is mr square by 4. This one. It is given to us. The moment of inertia of disk about an axis normal to the disk and passing through the point on its edge. Now they want the moment of inertia. They want you to calculate the moment of inertia of this body perpendicular to its plane and passing through one of its edge. ID is equal to mr square by 4 is lying in the plane, but ID is perpendicular to the plane, but it's passing through one of its edge. Try solving it.
So is x equal to 3.
Here again. Very good. They have said x is equal to 3. What happened? No one else is getting the answer or what? देखो जेई का क्वेश्चन है, सी दिवा जेई क्वेश्चन, यू सॉल्व इट इजीली. अच्छा, do you want me to solve? Haripriya, do you want me to solve? Haripriya, Radhika, Kanishka. अच्छा, you want me to solve it? See, moment of inertia, this is the thing. You can find out the moment of inertia about an axis passing through the center using your perpendicular axis theorem actually. Because I'll draw 3 axes similarly. This is say Ix, this is Iy, this is Iz. Iz is actually passing through the center of gravity, so I can write Ig. Now Ix plus Iy is equal to Iz using perpendicular axis theorem. But since about Ix and Iy, the body is symmetrical, so they both are equal. So 2Ix is equal to Iz. 2 into mr square by 4 is equal to Iz. So Iz I am going to get is mr square by 2. So once I have got Iz, which is Ig actually, I have to use parallel axis theorem now. The distance between them is 2 axes, ID, and this is R. So now I'll be using parallel axis theorem, doing it in the left. According to this parallel axis theorem, ID is equal to Ig plus M into distance between them is R square. R is the distance, so Ig is mr square by 2 plus mr square. So ID, the desired one, is 3mr square by 2. They have given this is equal to xmr square by 2. That's why I'm getting x as 3. This is the answer. Understood now? Do you want me to give some more question, or let me give you some question? This question you have already done. Okay, we'll move on to the next question, concept. Then actually the questions are asked mixed up. Mixed up questions are being asked. Oh, before that, let me tell you about moment of inertia of the uniform bodies. See, I'll give you the list of moment of inertias that you will have to remember, and I'll tell you how you will be finding moment of inertias for them for each of those bodies. Let me just give you the list first. Hmm. See here, the list will be appearing here. This one more. Okay. Now let me tell these things in detail to you. These formulas you will have to remember, but don't worry. I'll tell you a trick to remember how to memorize them. Actually, you need not have to memorize everything. You'll have to memorize a small part. See, these are the few moment of inertias that I have listed for you that you will have to remember. The important thing that you will be remembering is just remember few formulas. Like if you want to remember this one, you can remember this one. Here you can remember this formula. I'll just mark it out. Remember this one. Rest all formulas you can find out using parallel access theorem. I'll tell you how. Or is it one formula you remember? If you want, you can remember this I3 also. This one. Similarly, this sine square theta and all I will discuss later. This is not important. I3, I5 not important, but I'll tell you. In this, just try to remember one formula, this I3. Moment of inertia passing through this center and perpendicular to it. This diagram, this symbol they have given a notation. It represents moment of inertia of the body perpendicular to it. Means this one. Perpendicular to plane coming towards you. And here, similarly, for the circular ring also, remember one formula I3. Rest all you can find out. How? See, I have told you rest all you can find out, but how? Using perpendicular axis theorem and parallel axis theorem. See, what we will discuss now, this formula you have to remember. This. Here also, the formula that you can remember is I1 or I2. They both are same. Here, this formula you can remember, one formula. Here, for solid sphere, you can remember this I1 because I have told already. For hollow sphere, you can remember this I1. Okay? These formulas, the star mark formulas only you have to remember. Rest all things, because you have learned by now, you have learned what is parallel axis theorem and what is perpendicular axis theorem. I'll tell you how to find out. Or you can tell me. See, take it as a question. Here, you know what is the moment of inertia of this rod. This is a rod whose length is L and its mass is M. Okay. The length is L and the mass is M. Correct? Now you know the moment of inertia of this rod about an axis, about I3, which is perpendicular to the rod. Tell me, can you find out the moment of inertia of this rod about an axis perpendicular to it passing through the center of gravity? Can you?
Yes, so we can use parallel axis theorem.
Very good. You can use the parallel axis theorem, and how you'll use it? I2, which is Ig, plus M into L by 2 whole square must be equal to I3. So I2 plus ml square by 4 will be equal to what? I3 is equal to ml square by 3. So I2 will be equal to ml square by 3 minus ml square by 4. So it will be ml square by 12. See, you've got the result now. See, if you are able to remember, it's okay. But if you do not, if you're not able to remember, it's not at all necessary. You can just calculate using parallel axis theorem and perpendicular axis theorem. And why I'm stressing on applying the perpendicular axis and parallel axis theorem, because whenever questions will be given to you, like I have given the question, they were actually asked in 2023 JEE Main or this some JEE Main 2024. They will be asking questions of these types. So ultimately, you will have to solve the questions using applying this parallel axis and perpendicular axis theorem. So why not apply here also in your daily life? Okay. Now this is different. I'll tell you later. This I4 and I5, this I'll tell you later. Don't worry about it. Just remember the basic one. I1 is 0 because about this axis mass is not there. This is over, this is over. And I6. Achha. I6 also you can find. I6 is what? Again parallel axis theorem application.
Parallel to I1.
0 plus m into x square. That's all. So it is I6 is mx square. This is how you do it. So now come to circular disk. I told you the moment of inertia about I3 is an axis perpendicular to the disk and coming towards you is this. I3 is mr square by 2. Now they have asked you to find out I1 and I2. Both are same actually. They have asked you to find, first try to find out the moment of inertia about I5. Just tell me how you will do it.
Parallel to I3.
Parallel axis theorem. Very good. Now parallel axis theorem, how you will do it? I3 is mr square by 2. And I5 will be I3 plus m into r square. So it will be mr square by 2 plus mr square. So it will be 3 mr square by 2. Where is the result? I'm getting wrong answer or what? No. Correct. We have got now I5. Now coming to I1 and I2. How you will do it? Tell me. I5 you know, I3 you know.
Perpendicular.
Very good. Perpendicular axis theorem, because you already know I1 and I2 should be equal. They are symmetric, about which the body is symmetric. So you will just apply it. I1 plus I2 is equal to I3. because I1 and I2 both are in plane. So 2I1 is equal to I3. So I1 will be equal to I3 by 2. So your answer is like this, mr square by 4. The same. You have got it. No need to remember. Just remember this star mark formula. And if they've asked you how to find, if they've asked you to find moment of inertia about axis 4, how you'll do it? Again, apply parallel axis theorem. I2 is axis passing through the center of gravity. See, from here you can understand one thing. The axis passing through the center of gravity is not always perpendicular to the body. Here, I3 is also passing through center of gravity. I2 is also passing through center of gravity, but they both are perpendicular. But in both the cases, you can just apply the parallel axis theorem. You will get the right result. But the axis should be parallel to them. So here, if you apply, I4 will be equal to I2 plus m into the distance r square. This is what he has done. I2 is mr square by 4 plus mr square, it will be 5 mr square by 4. That's all. Easy. The way I am doing it now, the same way you have to do for everything. Circular ring also, this also, this is your work. You do it at home. And by the end of the day, you should be able to give me the answer. Whenever I'll ask you the moment of inertia, you should be able to give me the result that this is the moment of inertia. Because on moment of inertia, they are asking so many questions. Okay, now this one, I'll just write homework. These we have done. Try to do as homework. This one, and this one. Don't just neglect it. Like you neglect it na every day. You're not solving question when I'm giving you homework. But don't neglect it here. You will be at loss. Because these moment of inertia you'll be using multiple times. Now here, I1 and I2, I ask you to remember. I3 is perpendicular axis theorem, I1 and I2. I1 plus I2. It will be this is easy. Again, I3 and I1, they are in the plane. I3, I1 and I2 are, this is somewhat different. Later I'll tell you why I2 is equal to I1 and I3. I1 is equal to I3 and I4 is equal to I1 plus I3. It will be mA square by 6. Similar is the case, solid sphere, parallel axis theorem application. Find out how it. Okay, it is easy. Again for the hollow sphere, I2 is parallel axis theorem. Okay. Now we'll move on to the next part. It's okay that we found out the moment, we used the parallel axis theorem and perpendicular axis theorem for each of them to get our desired result that we did not know. But how do we get the original result that I have just star marked? These basic formulas I have given you, star mark this. How do we get it? See, basic integrations I'll tell you just for the sake of understanding. But these integrations I won't tell. Solid sphere and hollow sphere. If you want to see them, I have actually some student of JEE Advanced, he have asked me. So I have done the integration. Spherical integration is there. I'll just send you the link of that YouTube video. You can watch that later.
So are these integrations in class 11 or in 12?
Class 11?
ये वाली जो solid sphere और hollow sphere की integration है, वो questions mains वाले के लिए भी help करेगी?
Process help नहीं करेगा. जो integration process है ना,
result होगा.
वो ये result help करेगा. This result will only help, and you are expected to remember only this result and how to apply parallel and perpendicular axis theorem. That's all.
So ऊपर वालों के integration नहीं करने, बस sphere और hollow sphere.
नहीं, ऊपर वालों के integration, these integrations I'll tell you how did you get the result of the star mark, because you should know na how you are getting it, because they can do some changes in this, like mass density they will change, or something they will change. In that case, how you will find out? So you should know how you are getting it, but this complex integration for the solid sphere, it's not needed for you. If
Okay.
I'll just share the video, but no need to do it, not important. Now, how do we find out the moment of inertia for a uniform body, for the rod? What was the result? About 1x, one corner, na? I3, हाँ. This result I have asked you to remember, and this was what? ml square by 3. But how do we get it? The basic principle is, the problem here is, this is a rod, and this rod, on this rod mass is uniformly distributed, so the each mass on this body is at a different distance from the axis, so there is a problem. Now what we will do, we will divide this whole rod in an element of length dx, which are of mass dm, and each element is at a distance of x unit from the axis. What my theory is, what my procedure is, I will, because I am treating this point, this elemental mass, as a point mass, and the moment of inertia of this dm about this axis 3 is dm into x square, correct? M into r square. Point mass is m into x square only.
Yes,
Now,
sir.
what I will do is, to find out the total moment of inertia, I'll just integrate it. Means what I am doing is, integration means I am trying to add similar elements at different distances, similar element moment of inertia at different distances. So for that purpose, I am integrating it, dm into x square, and x will range from x is equal to 0 to x is equal to L, because the length of this rod is L. What, everyone got silent? What? Is it okay? Is it difficult? Easy?
Can you repeat that once again?
Eh?
Can you repeat it once again? I didn't understand.
See, what I am doing now, what my concept is, I have found out the moment of inertia of this mass dm, and then I am trying to add similar moment of inertia of different masses of same type of masses which are at different distances, because this is the moment of inertia is a scalar quantity, so I can just find the moment of inertia of each element and then sum them up. For that purpose, summing is what? Integration. So I am integrating the moment of inertia of each mass from x is equal to 0 to x is equal to L to find out the total moment of inertia.
Okay.
So, or you can use you can make a general formula, moment of inertia I is equal to x square dm from A to B according to the limits. This formula can be used everywhere depending on the situation.
Okay, sir.
Now, how to find dm? Can anyone tell me what is dm? The mass of total mass is capital M, length is L. What will be the dm? Ray, it's capital M by L into dx, na? For length L, the mass is capital M. For length dx, the mass will be M by L into dx, na? Or you can find out mass per unit length. Mass per unit length is capital M by L. Means for unit mass, for unit length, 1 meter length, the mass is M by L. So for dx length, it will be M by L into dx. Okay.
Yes.
0 to L x square into M by L into dx. Haripriya became silent.
No, sir.
M by L into 0 to L x square dx. Kanishka, are?
Yes, sir.
Actually, my doubt is, see, because it is very late now, my doubt is you guys are studying or sleeping because it becomes tiring. Because my problem, I have the habit of studying till late night. So I actually quite enjoy studying, taking class at late night or studying in the late night. I'm night person. But what I don't know about you.
So this time is okay for me.
This time. But what you have to do now, you have to just make some adjustment. Like if you have the habit of eating at 10 p.m. like this, then just try to complete your dinner by 9:30 or quarter to 10, like that. Just few adjustment you have to make. Because this shifting is final. After this, on Tuesday and Thursday, I won't change the class timing. See, we have got the result, ml square by 3. है ना? That's why this thing I have told you to find the ml square by 3 to remember. But I have told you how do we get this result. In the similar way, in the next class, I'll tell you how do we. Huh?
like derivation back करनी है या फिर
नहीं
direct
नहीं 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 नहीं. Derivation you need not have to remember. Just you have to understand the process. Why I'm telling you why I told you the derivation, because sometimes what they do na, in complicated questions like in JEE Advance, this mass density, mass per unit length, we have found out na, this lambda. What they do, they actually change this lambda. They say the lambda mass per unit length for the rod is A plus BX. Like I have given na, in the center of mass one question. Like that. The lambda mass per unit length is changing. In that particular case, you have to, instead of this m by L, you will be finding out the dm as lambda into dx. And the lambda value, you have to put A plus bx and then integrate. So that's why you have to know the basic process. If they change mass density or if they change something, you should be able to get the result. That's why I need to tell you this the way. Okay, in the next class, we'll study about how do we get for the circular ring. For circular ring is very easy. Circular ring, circular disc, and then rectangular slab, everything will do. But these hollow sphere and solid sphere I won't do, because they are over complicated for you. Spherical integration and those integrations will be asked. So this is too complicated for you. After class 12, I'll tell you. These complicated integrations they will never ask also. So let's end it. Keep solving questions. If you have any doubt, keep generating doubts. If you have any doubt, just send me. Don't think that it's late or early. Just send me the doubts whenever you get. If you are studying at night also, 2 p.m., 3 p.m., 2 a.m., 3 a.m., then also you can send. whenever I'll see, I'll solve that out and send you. Okay, let's end it. Bye bye.